So for our next classification, it is solvable by substitution. And we do substitutions because there are some DEs that are complex. So we use substitution to simplify them into either VS, exact, or linear to easily solve them. Okay. So let's go with Bernoulli. So one of the three. So for Bernoulli, it is basically our linear pero there's an added caveat. So let's say yung dv natin ulit is y and then yung iv natin is x. So y prime plus p of x y, so same pa rin dito. And then it is equals to q of x multiplied to y over to the power of n. So in Bernoulli's case, we have this dv term that is to the power of any number. So what we do now, once you manipulate the DE into this type of structure, we have to divide the whole thing by y over n to the power of n. So let's do that, y minus n, since it's a reciprocal, plus p to the power of x, and then this is y to the power of 1 minus n. So this is basically y to the power of 1. And then we do rules of exponent. Q of x is then left here. Nice. And what we do now is a substitution. So we can use any letters. So I will use Z. And we will equate it to our y1 minus n. So it becomes y1 minus n. And we will do implicit differentiation here. So this becomes Z prime equals 1 minus n, and then this is 1. 1 minus n minus 1 is basically minus n. And then this is dy or y prime pala. Y prime. And we can see this is basically the same formula here, same equation. So we can substitute it even further. So a very, very clean. And let's substitute it. So this becomes 1 over 1 minus n z prime plus p of x, and then this becomes equals to z equals to q of x. And then we can see that it is becoming a linear function. So let's take out yung itong coefficient. So it becomes like truly parang yung linear na structure that we know. So this becomes z prime plus p of x. So we're basically multiplying the whole thing by 1 minus n para mawala dito yung coefficient. So this becomes 1 minus n multiplied to p of x, z equals to 1 minus n q of x. Ayun. So in our case, for this, it is now a linear function. And then this whole thing, yung coefficient natin sa z natin will be our use for our integrating factor. So if and then 1 minus n. This is just basically a coefficient. Yung n natin is any number. Hindi naman it's variable talaga. And then so dx. Ayun. And then we multiply it. Pero we already know yung parang structure once we multiply all of it. So this becomes basically d, i.e. to the power 1 minus n, p of x, dx to z. And then there's the integration of 1 minus n e1 to the power of integration of 1 minus n e of x dx q of x q of x dx. And then what we can do now is once you've solved all this, tapos may constant, we substitute it back to z. So every instance that we have z here, we just have to substitute it back. So we know that z is equals to y minus y to the power of 1 minus n. So this is 1 minus n x, x, and y, 1, and tapos dito. Same lang. Ayun. And then that's for Bernoulli. So let's go to the next classification under solvable by substitution. So for homogeneous, we have the same structure actually to Vs and exact, which is m dx plus n dy equals 0. In this case, homogeneous means that all of the terms are of the same degree. Are same degree. So, so in this case, let's say we have x, y cube, and then xy square pala, dx plus y cube plus dy. This is a homogeneous function because yung ating terms dito next to our dependent variables x and y, it is equals to or totals into 3. So this is 1 exponent 2 and then this is 3. 3 and 3. Ayun. So again, just like parang VS and linear, you can actually identify what is a homogeneous. So another example could be like x cube, x squared, and then y cube dx plus 1 over x to the power of 1 over x. Yun. So in this case, yung exponent natin is negative 1 and then exponent natin is negative 1. Ay, dy is 0. Ayun. So just try to remember these types of equations. And then there are also special cases where we have e plus x and then y. This is basically yung exponent natin is just equals to 1 since it just cancels out lang naman. And this is compared to, let's say, linearity, which doesn't allow for e. Yeah. So just remember that. And there are other cases for homogeneous where you have to do rules of exponents, all that stuff. So just remember those rules. Yun. So for homogeneous, let's say if m is simpler, then we use the substitution of x is equals to vy. And then we do differentiation there as well. So this becomes dx is equals to v dy plus y dv. Ayun. If n, so yung function dito, is simpler, simpler than the other function. So if m is simpler than n, then this one is, if n is simpler than m, then we use y is equals to u x, and then we differentiate it as well. So dy is equals to u dx plus x du. And what we do is basically, let's say, like this, we can substitute it. So we can substitute the x within all of the entire equation, and then we can also substitute this with this, v dy plus y dt. And in the same way, we can substitute yung, let's say, yung n is simpler than m. We can use yung dy because u dx and x du. And that's it. From there, you will find that it will become a variable separable equation. So very easy na rin. So you can just integrate it accordingly. And then after that, you have to substitute it back to x in terms of x and in terms of y. So, substitute pa. And that's essentially yung thought process ng homogeneous. So just remember, it will always go back to variable separable. So, very nice. So let's go to the last classification. So our final classification is other substitution methods. Other substitute methods. So there are two in particular that you will see in quiz 1. So the first is reduction of separation of variables. Ayun. So is this VS11? Pwede um like reduction of separation. Um yeah. So for this one, it has this fine general function, which is, let's say, yung dv natin ulit is y, and then iv is x. So it is dy over dx equals to a function of ax plus by plus c. Ayun. And what we can do is u is equals to ax plus by plus c. And then from there we can substitute and all of that stuff. So let's say we have example number. Right, let's have an example, which is dy over dx is equals to x plus y plus 1. So simple example squared. So this is a function of x plus y plus 1. And we can then substitute it to any letter. So in this case, it is u. And then we differentiate all of it. So this becomes u prime or du pala. So we're differentiating in terms of x. So there will be implicit differentiation. So this is du with dx. And then x will be equals to 1 since we're differentiating in terms of x. Yung iv natin, iv. And then this is plus y, dy over dx. Dy over dx. And then constant will be equals to 0. And then we can actually try to, yeah, we can substitute this into this, changing the subject to dy over x minus 1 dy over dx. Okay. So we have that now, and if we substitute it, it will be du over dx minus 1 equals du squared. Ayun. Very nice. And then we can make it more simpler. So we move this to the other side, yung 1 natin. And then we can do basically variable separable since there's no the two variables that we have are separated. So this becomes 1 over u squared plus 1 du is equals to prime integration dx. Ayun. And then from there, you substitute it back. Yung u is equals to x plus y plus, yeah, once you've integrated all of it. And that's for reduction of separation of variables. Ayun. Actually, it is reduction to, apologies, reduction to separation of variables. Ayun. So let's go to the next other substitution method. So our final classification is substitution suggested by the equation. Ayun. So that basically means anything goes. You can substitute whichever way you can in order to simplify the equation to either variable separable, exact, or linear, or even homogeneous. So in our case, let's say, example, we have 5x plus 3ey, e to the power of y, multiplied to our dx plus 2x dy equals 0. So we can see it's not a variable separable since there is an addition here. It's not exact since you can even mentally differentiate na hindi pwede. And it is not linear since x is here with dx and even, I mean, there is the presence of ey itself. And then it's not homogeneous as well. So what we can do is substitute it. So if all else fails, we can substitute it. And we can substitute yung parang variable that is complex, which is ey. So always try to look for lin, trigonometric, yung lahat ng, all of them that are complex. Yes. So ey, and then we differentiate ulit, implicit differentiation natin. So this is u prime equals to ey y prime. And then we substitute it accordingly. So this becomes 5x plus 3u. This becomes 3x plus 2x. And then this becomes u prime. Diba? And then what we can do is basically divide everything. Okay, cos 0, divide everything by dx para mawala to. So this becomes 5x plus 3u plus 2x and then u prime equals 0. And we can see that it became a linear equation. So from there, we can do yung process of linear solution. So yung IF and then yung pag-integrate and all that stuff. And from there, we are now done with classifications of DEs. And let's now look at sample problems from our reviewers from syntax. This ends part 2. Go to part 3 to find our discussions for the sample problems. Thank you so much for watching. You may avail syntax tutorials by scanning the QR code flash on your screens later. Once again, this is Elijah Go from Syntax, paving your way to excellence.